Okay, we're going to go on now to topic 3 of chapter 1, fractions and mixed numbers. Now, don't often tell jokes, but this is sort of an interesting one. Ties in with our study of fractions here. Yogi Berra, who was a catcher for the New York Dodgers that later became the Los Angeles Dodgers, a ball player and a sports announcer now, is noted for sayings or things that he presents, and they're called yogiisms. Well, one of the yogiisms sort of deals with fractions, and I like to use it when we're talking about fractions. And that was because every Friday night he would go to the pizza parlor and order a pizza. Now, the pizzas were all just one size, they didn't have any different sizes. But he said to the pizza fella, he said, Giuseppe, he says, tonight, he said, I'm not too hungry. So instead of cutting it into 8 pieces, only cut it into 4 pieces. And you might say, well, what's going on here? And I told this story to my grandchildren, and the thing of it is, what's going on? Well, I've made a picture of it, and you can probably see from the picture, he's getting the same amount of pizza, whether you cut it into 4 pieces or whether you cut it into 8 pieces. Now, in one case, you're eating 8, and the other case you're only eating 4, but you're getting the same amount of pizza. So the thing is, that's the yogiism of it, that when we think of a fraction, taking something and making a ratio of it, and if we put 1/4 in a sense of this over here, and 1/8 in a sense that I didn't do that too well there, that over there, having one piece, you're not getting the same amount of pizza. The key to fractions is you're getting one of equally divided parts. One of equally divided parts. So the one that you're talking about over here is not the same as this one over there. Because when we do fractions, we're doing a comparison. 1 out of this much. 1 out of this much. So these ones are different. And throughout this lesson, we're going to talk about equivalent fractions. In order to make this one equivalent to this one, or I should say this one equivalent to this one, we have to make our denominator an 8. Now, in order to make a fraction equivalent, we're going to multiply that fraction by a 1. We can multiply anything by 1 and not change its value. But when we're making equivalent fractions, to get an equivalent, our 1 has to be what will make our denominator 8. And that's going to be a 2. So if we multiply our denominator by 2, we have to multiply our numerator by 2 also. And what is 2 over 2? 2 over 2 is 1. 1 in the form of 2 over 2. So that would make this equivalent fraction 2/8. So now our denominators are 8, both of them, And then we have a valid equivalency between our numerators. Here, this is actually 2/8. This is 1/8. So if we were to add this together, we'd end up with 3/8. And we're using that little yogiism for a number of things. So the word quotient, by the way, refers to a fraction. Quotient is another name for fraction. And the top part of it, which we've been saying, is our numerator. There's our fraction bar, and it should be drawn horizontally. You'll see it sometimes written 2/9, which is not very good. I don't like that at all. Write your fraction bar horizontally. And it's also, by the way, a grouping symbol, as you'll see later. And then the number on the bottom is a reference number to how many equal pieces there are. And then this is how many of them do you have. That's what 2/9 means. And visually, it's dividing something into 9 parts, and you're shading 2. Okay? All right, let's go on. Now, some other things about this is that in the statement, 3 times 5 is 15. 3 and 5 are called factors. We're working on vocabulary. And 15 is called the product. The raised dot to the center of it indicates multiplication. Now, another important vocabulary word is prime numbers. Prime numbers, by definition, are numbers whose only factors is 1 and itself. The only factors of a prime number is the number 1 and itself. So the first prime number we have is 2, because these have to be different. Then the next prime number is 3. 4 is not prime, because 4 has 2 times 2. Then the next prime number is 5, and then 7, then 11, then 13, and so on and so forth. These are prime numbers. Now, when we are looking at a fraction like 5/11, we say this is in a simplified or lowest terms form if both the numerator and denominator are prime numbers. And you can't do any simplifying or canceling out that I'll show you shortly. So let's go on here. And here they're developing what prime numbers are. Now, all of the other numbers that fit in, let's say over here as a 4 and a 6 and then an 8, 9, 10 right in there. These numbers are called composite numbers. The 4 has the factors of 1 and 4, but also have the factors of 2 and 2. And the 8 has a 1 and an 8, a 2 and a 4, but remember the 4 is not prime. So that would have a 2 times 2 times 2. These would be the prime factors of 8. Okay? Or these are the prime factors of 8. Prime factors of 4. And we'll be getting on to that. Now, which are prime? As we look at 40, that's not prime. Any even number is not prime except for 2. When you look at 63, now a little rule here is what we call the rule of threes. If we add the digits, we get a 9. Now, is 9 divisible by 3? Yes. So this happens to be 9 times 7. So this number is not prime. It is composite. And they give you the examples of it as well. Now, here they're showing us a method of getting to the primes. The method I like to feature is this. Since it's even, I know I can take a 2 out. That's prime. This gives me a 20. Since that's even, I know I can take another 2 out, and that's 10. And then that's even, I can take a 2 out, and I get 5. Now I have my primes all along the side. This is another way to do it. And for 63, I know by the rule of threes, I can take a 3 out. And this gives me 21. And I can take a 3 out of there because that adds up to 3. And that's 7. So these are my primes. Again, there are different ways to do it. And you'll be working it as you do your practice and your quiz-me's for mastery. Now, what they're saying is we can make equivalent fractions by multiplying any fraction by 1, but if that 1 is in the form of c over c, we then get a new equivalent fraction, ac over bc. And that's what they're showing you here. Now, when we simplify fractions, what we want to do with our fraction is sort of factor it into its prime factors and see if we ever have ones or a c over c that we can then cancel out. And that's what they're showing you here. So let's do and look at some of these. We don't always have to write them out because they're written out here. So we take 42 over 49 and factor it. And there's a 6 times 7, and there's a 7 times 7. Now we notice here in blue, 7 over 7 is actually a 1. So our common simplified form would be 6 sevenths. Now, some of you, as you look at this, may use the technique of this is 6 times 7, and this is 7 times 7. I'm going to cancel out the 7. Or I'm going to look at that and say I can take a 6 out of there, and or I could take a 7 out of there, and I'm left with a 6, a 7 out of there, and I'm left with a 7. So this is the technique. If you can shorten it because you know the factors of this, this is a 6 times 7, 7 times 7. Now, when you factor b into 11 and 3 times 3, there are no common factors, so this is its simplified form. Now for 88 over 20, again, you're going to factor it into its prime factors. Or you might say I could take a 4 out of there, and that's going to be 22. And I take a 5 out of there, and that's going to be, a 4 out of there, and I'm going to get 5. Again, there's your 1. There's your 1, which is a 4. 4 and a 4. And then that's how you get the simplified form. And out of here, you might say, oh, I can take and sometimes you might do it in pieces. Now this is going to be 6 times 9. And this is going to be 9 times 7. And you see you have a common 9 that you're going to cancel out. So this is reduced to 6/7. Now here, this was a proper fraction. This is an improper fraction. And you might say, well, what can I cancel out? Well, I know I can do a 2, and I know I can do a 4. Let's try the 4. 4 goes into there once, and that would be a 16. And 4 goes into there 3 times. So you would get this, and I'm going to check my, and that is correct, and it's always good to check your work. Now as you look here, 7 is prime. Does 25 have a factor of 7? No. So this is in its simplified form, and that's what we're shooting for. And you want to develop a technique. This is the simplest technique where you get them in their prime factorizations, and you see if you have any common factors. Now when you're taking the test, you want to use your best technique so you get your highest score. Now in our textbook, they're showing us some wrong things here. Here they say, well, let's cancel out the 5s. No, you can't do that. That would be completely wrong. And this is completely wrong too, because you cannot cancel out terms. You can only cancel out common factors. Okay, now when we are multiplying and dividing fractions, here are the basic rules for multiplication. You're just going to multiply the numerators, multiply the denominators, and keeping in mind that our denominators can never be a 0. So when we multiply this, here's what you want to do before you do that, though. Can you see that you have a common factor of 5? So we are allowed to cross cancel like so. So then what we end up with is 2/39. Now if you had multiplied this by this, you would have gotten 10 over whatever this is, and then had to cancel out. By canceling out before you actually execute the multiplication, it saves you having to do it later. And now that is simplified. And they're showing that actually right here too. By the way, the book usually shows what we're talking about. Okay? Now for this practice, we'll do that because I think students often need to do work on fractions here. So this way you can't cancel anything, but this way you can. This is going to be a 1, and this is going to be a 3. So we get 7/24. And then that is simplified because we canceled ahead of time. Now, another thing we want to look at as far as our definitions go is the word reciprocal. By definition, when you multiply one term by another term, there's something in here, it's not zeros, and the product is 1, then these were reciprocals of each other. Remember, that's not a 0. I should have used a box here. Okay, so if we see the fraction 2/3 and the fraction 3/2, and notice everything all cancels out here. Or you get 6/6, which will cancel out. You end up with a 1. Then these fractions are reciprocals of each other. Now, what do you notice about them? Well, that the reciprocal of this is just this flipped over, where the 3 goes to the numerator and the 2 goes to the denominator. And the product is always a positive 1. Now, every number in our number system is written over 1. We just don't write it. So the reciprocal of 5, in a sense, 5/1, is, again, flip it, 1/5. And it gives you the product. Now, we use this word reciprocal here because when we are going to divide fractions, and let me write it out here for you. If you have A/B divided by C/D, when we are doing that process, we write it as a multiplication. Right here it's a division. It's going to be A/B. We take our division sign, change it to multiplication, and then take the reciprocal. So this now becomes D/C, and that's what they're showing. And again, none of these can be a 0. All right, so let's do some examples, and we'll use what's written up there as well. So what I want to feature here is the process. So here you see 2 fractions, and we are dividing. Now, don't make the error of trying to cancel out here. We don't cancel out in division. We only cancel out in multiplication. Okay? It would be wrong to cancel out here. But what you do is you write the first term, take the division sign, change it to multiplication, take the reciprocal of the second term, and now we have it. Now, if you could cancel out here, that would be great, but you can't. So there is your answer. Now, keeping in mind this is 14/1. Write the first term regularly, convert the division to multiplication, and take the reciprocal of this. And again, if you could cancel out, you do so. And here, look, you can go 7 goes into there once, 7 goes into there twice. So there is your answer. Now this stage you're often going to do mentally, and you don't have to do it all of this. You just want to try to see which ones you can cancel out. Okay, first term is written exactly the same. Change division to multiplication. Take the reciprocal, and notice lots of stuff will cancel out here. 2 will go into there 5 times. 2 will go into there 4 times. So you end up with this. Okay? And you'll have some practice. Remember, this is over 1. And you have to convert from division to multiplication. Now, when we are adding and subtracting fractions that have the same denominator, that's real easy, because all you do is you add your numerators over the common denominator, or subtract them over the common denominator, and then, if you can, simplify the fractions. So these are all worked out here. And again, if you need that, study it, check it out. And here are just some other examples. Now, when we are going to add when they're different denominators, as we did starting off, in order to legitimize what we're doing and have the numbers be equivalent, we have to have equivalent fractions whose denominators now are the same if we're going to add our numerators. So here, notice if we just divided this into 4 parts, this is shaded is 3/4. But if we divide that into 16 parts, the shaded parts are 12/16. These are equivalent fractions. Well, without making a picture, how can we do that? Well, we said we could do it by multiplying this fraction by a 1. But if we want to make this denominator 16, our 1 is going to be 4/4. So when we do our multiplication, we get an equivalent fraction of 12/16. Okay? This is what they're showing us here. So they're asking us here to write 2/3 with a denominator of 12. This is how you set it up here. And it's not 12, it's 21. Okay, so equivalent denominator. Well, what was our technique? We're going to multiply this by a 1 that will make this denominator a 21. Well, it's going to be 7/7 is 1. But now it makes this denominator 21 and this numerator 14. Okay? And you'll have some examples now to work out. And we want to have a strategy for this. Well, let me show you a way to do it. Now, your book shows you a way too, but I always like to put my 2 cents in. So we have 2/5 plus 1/4. Well, the first step I like to use is what's your common denominator going to be? And one of the common ways to figure it out is just to multiply these two together, and that'll make it a 20. Now, this is 2 times 2. There is a way to figure this out, and I will show you that maybe in a little while. But for now, it's 20. Now, my next step is, what do I have to multiply the 5 to make it a 20? Well, I have to multiply it by a 4. So 4 over 4 is 1. So this now becomes an 8. What do I have to multiply this 4 by to make it a 20? Well, a 5. So I'm multiplying this by a 1 in the form of 5 over 5. So this becomes 8 plus 5 now over 20, which is going to be 13/20. Now, this is simplified because there's no common factor. All right, let's do these other ones, and they have them set up. So again, we'll look at the way the book does it. That's the first one, similar to the way I did it. Let's look at some of the others here. And again, I'll show you my way too. So I won't write it out again, but what's my common denominator going to be here? Well, can you see it's going to be a 12? So I had to multiply this by a 1 in the form of 2 over 2. So that gives me then a 38 minus 23. Yeah, I'm doing this at home, so we do get calls. So this then becomes 15/12. And we notice now there are common factors we could take out. We can take a 3 out of there, and that would be a 5. And a 3 out of there, and that would be a 4. So our answer is 5/4. Okay, now for number, or part C of this, I don't quite see the original here. But anyway, there it is. Let's go back to the original because I can't figure that out too well, and I want to try to do this quickly if I can. Okay, so here it is, and what would be my common denominator here? Well, 2 times 11 is 22, so 22 is our common denominator. And then what are we going to do? Well, we have to multiply this one by 1 in the form of 11 over an 11. So this gives me an 11 there. That's 22. And this is minus. This is already there. And this I'm going to have to multiply by a 2 over 2, which is a form of 1. That'll give me a -4. So now I can add my 2 of these together, which gives me 11 minus 21, which will give me a -10 over 22 that I can simplify a little bit by taking a 2 out of each one, and this will give me a -5 over 11. Okay, well, you'll be practicing. This is a way to do it. There's other ways, whatever you're comfortable with, as long as you're getting the right answers. And speaking of right answers, I see I did copy that one down correctly. So again, looking at your original, this was a positive 17. I guess I had it written as a -17. Yeah, I see when I wrote that originally, I had obliterated the positive sign. So I wrote it as a negative. If it was negative, this would be correct, but it's not. It's a positive. So again, I'm jamming it up there, and that can lead to an error. So neat orderly would be the name of the game. Let's go on. Now, performing operations on mixed numbers. This gets to be a challenge here. And there's a couple of ways to do it, but we'll follow the one they're using in the book, keeping in mind there's other ways. So what we do is we change a mixed number to an improper fraction. And the technique for that is to multiply the denominator by the whole number, which gives you 15, add the 1, which gives you 16 over 5. They're doing it a little different way. That's okay. The way I'm used to, 5 times 3, 15, plus 1, 16 over 5. Now, when we divide something, again, the first thing I would do is convert it. So 8 times 2 is 16 plus 1, 17 over 8. 3 times 1 is 4, 5 over 3. That's going to be 17 over 8. Change this to multiplication. Take the reciprocal, and you get 3/5. Now, notice you can't do any cross-canceling here. So this is going to be 51/40. Now, when you get to this answer, if they want you to leave it as an improper fraction, that's okay. Otherwise, you have to make it a mixed number again. Well, 40 will go into 51 once, with 11/40, your remainder, or whatever's left. All right. I've recalled in other years students had problems with this sometime. So you just have to work on your technique and practice it. Now here is a subtraction, and I will illustrate this for you as well. So I would write it out here, 50 1/6 minus 38 1/3. Now, in order to subtract these, you have to have common denominators here. So our common denominator is going to be 6. So this is 1, and this I'm going to multiply by a 2. This becomes 2/6. Now I can't subtract this because there's nothing there. So I have to borrow here. I'm going to make this now 49, and I'm going to borrow a 1, which is 49 plus 1, but that's going to be in the form of 6/6. So I'm going to add it to this one, so this now becomes a 7. 6/6 plus 1/6 is 7/6. Now I can do my subtraction. This becomes 5/6, and this becomes 11. I'm subtracting 38 from 49, and that's what we get here. Now they do it a similar way, and that's good. And here's just another example that you will practice. I see this lesson's getting a little bit long here, and I think we have finished. All right. Well, good luck with your work with fractions.